Alright, in this video we're going to take a look at solving and graphing inequalities on a number line. So solving inequalities is a lot like solving equations. The biggest difference is that with inequalities, typically you'll get an infinite number of solutions. So for instance, if we get something like x is greater than negative 4, there are an infinite number of values that you can substitute in for that inequality to make it true. So for instance, 0 is greater than negative 4. 1,000 is greater than negative 4. Negative 1 is greater than negative 4. 8.675309 is greater than negative 4. So inequalities will typically give you an infinite number of solutions, whereas equations, they only have an infinite number of solutions when we see those all real numbers answers. So most of the time with equations, we only get maybe one or two solutions, but with inequalities, typically we get an infinite number. So for visual solutions to inequalities, since we can't list every possible number as a solution, every possible number that's greater than negative 4, we don't want to list it out, we can shade a region on the number line to represent that solution. So for instance, on a number line, all the values on the number line that are greater than negative 4 are to the right of negative 4. So any number that's part of this shaded region here on the number line is a solution to that inequality, x is greater than negative 4. So if your variable's on the left-hand side when graphing an inequality, you can use the following table to help you graph it. So in other words, if you have x is less than or x is greater than, you're going to use an open circle at that value, like x is greater than negative 4 will be an open circle at negative 4 on a number line. And the reason why we use open circles represent where it cannot actually equal the value. Closed circles represent values it can actually equal. So we'll use closed circles with things like less than or equal to and greater than or equal to, and we'll use open circles for less than and greater than. Now, an additional benefit of having your variable on the left-hand side is when you go to shade your number line, notice this inequality symbol, this less than symbol, is pointing to the left. That is also the direction you shade. But again, you have to make sure that your variable is on the left-hand side first. If it's greater than or equal to, notice again, if my variable's on the left-hand side, the inequality sign is pointing the direction that I have to shade. So example 2, graph each of the following on a number line. We're going to start with x is less than 2. Here we have a 2. It's going to be an open circle because it's not equal to 2. So it can be very, very close to 2, but it can't equal 2. And then we're just going to shade everything to the left. So any number that's to the left of 2 on a number line, like 0 or negative 100, will make this inequality true. When solving inequalities, remember to flip the inequality sign if you multiply or divide both sides by a negative number. So, for instance, in example 3a, we have 3x minus 5 is greater than negative 17. We're going to add 5 to both sides, so we're going to solve it just like an equation, and then divide both sides by 3, and we get x is greater than negative 4. Now again, we are dividing by a positive 3. If this was a negative 3, we would have to flip this inequality sign around, but it's not. So x is greater than negative 4. This is pretty much what we saw earlier. So because it's greater than, open circle at negative 4, and then shade everything to the right. So as far as this course is concerned, if you want to put additional values on your number line, you can, but I usually just focus on the number or numbers at a time. So. All right, part B, 2 times x plus 4 and then minus 5 is greater than 2x plus 3. So we're going to start by distributing the 2 to the x plus 4 on the left. We get 2x plus 8, and then minus 5 is greater than 2x plus 3. We can combine like terms on the left-hand side. 8 and minus 5 is 3, so we have 2x plus 3 is greater than 2x plus 3. If we subtract 2x from both sides, now our variables are gone. So we saw this in the last video. When our variables cancel out, we have to look at what is left over. And in this case, we have 3 is greater than 3. Now here, we're saying that this 3 is bigger than that 3, which is a false statement. It's not greater than 3, it's equal to it. So if it were greater than or equal to, that would be a different story. Then it would be true. But because it only says 3 is greater than 3, that's not true. That's a false statement, which means no solution. Now, to graph no solution answers on a number line, you just don't graph or shade anything at all. So you can draw the number line, but you just don't shade it like we did with the x is greater than -4 in the last example. All right, example C, we have 3 times the expression x plus 1 is greater than or equal to 3 times x and then plus 2. So we'll distribute the 3 on the left-hand side. We get 3x plus 3 is greater than or equal to 3x plus 2. Subtract our 3 x's from both sides, and we have 3 is greater than or equal to 2. Now this, again, our variables are gone. This is a true statement. So because it's a true statement that 3 is greater than or equal to 2, that means any value we want to plug in for x will make the left side greater than or equal to the right side. So our answer is all real numbers. And to represent that on a number line, because every single possible value of x will make this inequality true, we just shade the entire number line. So all real numbers, shade the whole thing. No solution, don't shade anything at all. So, all right, that about does it for this video. Thanks for watching. I'll see you.